the same. It's still an essentials or like a beginning statistics class. No, this one doesn't have it either. They just list Z's and then they just list proportion. So yeah, but sometimes you might see a Z-score that they put negatives. Okay, are we okay to move on beyond this? Yeah, okay, all right, good. So now we get to this fun part. Okay, we could do, well, I mean, I know you all can do Jimmy, Susie, Linda, and Bob's Z-scores. Okay, remember you take their raw score, which is this right here. Okay, Jimmy got a 68. You subtract the mean, which they told us the mean is 50, and you divide it by 10, right? That's the standard deviation. So that's how you would figure out Jimmy's Z-score, right? And you do the same for Susie and Linda and Bob. Okay. Any questions there on how to get the Z-scores? No? Okay. Remember, raw score minus the mean divided by the standard deviation. Okay. Okay, good. Now what we need is the percentile ranking, right? We need the percentile. It's not hard, okay? It's not hard. So let's see, I wonder which one. Maybe I'll use this guy right here because it's already drawn for me and maybe I won't mess it up, okay? So I'm gonna minimize this one just so I can get some more space here and I don't have to worry so much about the writing. Okay, let's see, I'm gonna push you guys down. Okay, all right, so let's play pretend. Sorry guys, sorry. Oops. Let's play pretend and we're gonna pick somebody else that maybe could take that MMPI, okay? So remember, let's see, I'm gonna write it right up here. The MMPI has a mean equal to 50 and a standard deviation equal to 10, okay? So let's pick somebody, I don't know. I was trying to come up with names of people that I wouldn't have in my class. Let's pick Tim, okay? And let's say Tim's score was, I don't know, a 54, okay? A 54. So in order to get percentile ranking, you have to know the Z-score. So we have to calculate the Z-score first. So Z would be equal to the raw score minus the mean divided by the standard deviation. So I get 4/10 and I have, don't make fun of me. Is this going to be 0.4? Yes. See, I'm telling you, I guess I'm horrible at math. Okay, so he gets a Z-score equal to, sorry, that looked too much like a, all right, equal to 0.40. Okay, now it's positive, right? It's a positive Z-score because he had a score of 54 and that was above the mean. Okay, so he has a positive Z-score. He's at 0.40, which we'll put, I don't know, maybe right about here. Okay, now to find the percentile, all right, we have to do a couple things. One, we need to know what in the world does percentile mean, right? So I'm going to type it over here so I don't have to write it. Percentile I'm just saying percentile. Of course, the percentile ranking, percentile, same thing, okay? Percentile is equal to all scores equal to and below a particular z-score. Okay, so percentile is equal to, or is all the scores equal to you and below. Okay, equal to you and below. When you hear, like, say, I tell you you're in the 84th percentile, that means that you are equal to and above 84% of the people out there. If you score in the 90th percentile, that means you are equal to and better than 90% of the people out there. Einstein was in the 99.9997th percentile, meaning he was smarter than 99.9997% of the people out there. Okay. If you are really low and below the mean, let's say someone told you you're in the 5th percentile, that means you're equal to and above 5% of the people out there. Okay. We just got reading results for Matthew. He has dyslexia. He's in the 8th percentile. So for little kids his age, he is reading equal to 8%, or he only reads better than 8% of the other kids out there. Okay, so you can see now how percentile works, I believe. All right, so knowing that, okay, we need to know that it's equal to and everybody below. Okay, so we have to have that visualization in our head to help us figure this out. Okay, so what this means is we need to find, right here we have Tim. Okay, let's see. Oh, do I draw? Why isn't it doing it? Tim, come on, Tim. Did it start to freeze on me? No, okay. So here's Tim, right? With his 0.4. I'm gonna try and do this as best as I can. If we drew a line right here, right? We have a line where Tim is, and then we have this imaginary line where the mean is, okay? So what we're trying to find out is the proportion or percentage of people at and below Tim, okay? And so how we figure this out is we need to find this proportion in here, okay? And how do we find this proportion in here? Does anyone have a guess? It's add a z-score to the mean.
Okay.
There's a little hint. We're trying to find the proportion between the mean and a z-score.
So it's like looking at the B column?
Yes, that's exactly right. It's looking at B column in our book, okay? So if you guys, let's see, if you have it or if you just trust me, I have it here, and I get 0.1554. Oops, that's a little high. 0.1554 was right there in that proportion, right, which we know is B column, okay? Now here's where the visualization happens. All right, if it's everybody equal to Tim and below him, we just found this proportion in here. Is that our number, or do we have to find more? What about all of these people that are below the mean? Right? We need all of these guys that are below the mean. Tim was above the mean, but we can't forget about everybody that's below the mean, okay? And I believe we talked about this, that this proportion in here will always equal 0.5000. The proportion below the mean or above the mean is always 0.5000. Do we remember that? I can't see y'all's faces. Let me see. Do we remember that or no? We don't remember that? That's okay. So that just is, okay? It's half the distribution is below the mean and half the distribution is above the mean, okay? So that value right there is always going to be 0.5000, okay? You can check that also, like the proportion above the mean is also going to equal 0.5000, and you can check that by adding B and C column. If you ever add up B and C column, they're always going to add up to 0.5000, okay?
So we get, so anything below or above the, you said the B column is that number.
Anything below, above and below the mean. I might have just confused it. Let me show you this and then I'll go back. Okay. I might have kind of messed that up and I apologize. So let me show you this and just write this real quick. Okay. Sorry guys, you need to go to music because you need to figure out what you have to do. Okay. So to find the percentile, that's an L, percentile for a positive. What you do, and this is going to be true every single time, okay? The percentile for a positive, you're always going to add B column, I should have typed it, B column plus the 0.50000. Let me see. Okay, I'm just going to stick this somewhere. We'll just put it right here. Okay, let me erase all this now. I can write what I have to write. Okay, so for a positive, we're always going to add what's in B column plus 0.50000. So for this example, we get 1554 plus 0.5000. So you just add those up. Okay. And we get 0.6554. To turn that into a percentile, you just slide that little decimal over 2 times, right? Remember that? That's one of the only things I remember from math. So in this example, we get that Tim is in the 65.54 percentile. I'm going to do another example because I think I messed that up. Okay.
I'm sorry, what did you say the 0.5000 is? What is it called?
Yeah, so that's, it's not called anything. It's just whatever is left in the curve below the mean. Okay.
Okay.
Yeah, that's the part I know I messed up, Susanna.
And that number is always going to be the same, or
Yeah,
it'll
the
change?
0.500 is never going to change. It's absolutely never going to change. Okay.
Okay.
Yeah, the only thing that's going to change in this example, or when you're looking these up, is going to be B column. Okay. And that's going to be dependent on whatever the Z-score is. Okay. So let me go through and erase some of this scribble here so we can play with this a little bit better, and it won't, hopefully it'll make more sense. Okay, so a few things to know, right, about this normal distribution. Remember, I keep hounding certain things, that it's bell-shaped, that it's unimodal, but the most important thing that we need to remember about the normal distribution is that it's symmetrical, right? It's symmetrical. It also has certain properties to it that will never, ever, ever change. Okay. And a few of those things are, well, there's lots of them, but a few of them are these certain properties right here. So right in the middle is the mean. We know that. Okay. We know that on one side below the mean is going to be 0.5000 proportion. I think sometimes it's easier to visualize it in percentages, right? If we moved that decimal over, it's 50%. 50% of people are below the mean, right? Yeah, I see that light bulb went off, Natalia, right? And then 50% of people are going to be above the mean.
Because it's half and half of.
Yeah, right. It's half and half. I know. I knew it. I knew it when I was doing it earlier. I was like, I messed this up. I should have explained this part first. Okay. So half and half, right? Half the people are above the mean and half the people are below the mean. Okay. The entire thing added up all together will be 100, right? 100% of the people. Okay, so since now we know that, that's just it's just a given. That's just the way it is. It's always going to be that way. So when we looked at Tim and he was a little bit above the mean, right? He was a little bit up here. To find out all the scores equal to him and below, we have to find that little piece right here, this little chunk right here, and then we just add up everybody that's below the mean, okay? Because B column will only take you to the mean, right? It only gets you as far as to the mean, and then you need to find everybody that's below the mean, okay? Does that help a little bit? Yeah, should I have started off with that first? Yes, right. See, yeah, even for teachers, we learn along the way. I apologize for that. So positive, for a positive Z-score, when you're finding the percentile ranking, it will always be find the B column and add it to that 0.50000. Okay.
Now you say there that it's a positive Z-score. Now
Yeah.
what if it's negative Z-score?
Excellent question. I love it when you ask questions that just lead right into the next example. So yes, so that's perfect. Okay, well, let's see. I'm not going to erase that. Let's erase, come on, guy. Oh, don't tell me okay. Let's go with somebody below the mean, okay? So the mean is 50. I need to pick a score below 50. Anybody have any suggestions on a number we could do?
Let's see. From the table, you mean?
It doesn't matter. You could just pick a number below 50.
Below 50, 38. Negative 38, yeah.
Okay, 38. Okay, and I like how you're sitting there, you're saying negative, right? I heard you say negative. So that means your brain is already thinking, you already know it's going to be a negative z-score, right?
Yeah.
You already know that. So that's so good. You're there. Okay.
I'm sorry, I just have a quick question.
Oh yeah,
So
go for it.
anything below 50 will be considered a negative. It just won't show the negative sign, or is that?
Right. Well, I guess like we know it would be a negative z-score, and the z-score can have a negative. Okay, it can. And it should, right? It would be correct to write it negative whatever. The only place you're not going to see a negative, Susana, is in the table. Okay, so you just have to know, okay, well, I'm still just looking up this value. Okay, does that
Okay,
make
so like
sense?
38 would be considered negative in some sense, I guess.
Well, no, it's his raw score. We just know it's below the mean because they tell us that the mean is 50.
Oh, I see. Okay. No, I
Does
see
that,
that.
yeah? Does that make
Mhm.
sense? Okay, yeah, it's just kind of like thinking like, oh, it's below the mean, so I know the z-score is going to be a negative.
So if it was, let's first say the mean was, instead of 50, it was 60, you would have to get something, like if it was 58, then that would be below the
That's
mean,
right.
which, okay, now I see.
Yeah, it all depends on what the mean is and yeah, whatever the mean is for that thing that you're looking at. Okay, and that could change all the time too, right? Oops. Oh my gosh, my handwriting got really bad. Okay, 38 minus 50. Matthew took my phone.
It's
Negative
negative 12 over 10.
Thank you. Negative 12 over 10. And so then that should be negative 1.20.
Well, do we always add the 0 or do we just put 1.2?
Oh, it doesn't matter, Christy. If you put negative 1.2, that's fine. I will put 2 decimal points, even if it's a 0. I'll just do that. And then just so you know, in the table, it'll be 2 decimal points like that also. Okay. But it's the same. Okay. It's the same. And you could put negative 1.2. That's fine.
Okay.
All right. So we got, I don't know how you would pronounce that, Cassie or Casey. So we got the z-score for, let's say, Cassie. And so now to find the percentile. Okay, I'm just going to erase some of this real quick. Okay, to find the percentile, remember, let's visualize in our head. The percentile is everybody be equal to and below you. Equal to and below you. So I think, drawing these distributions out just so you can visualize it. Okay, that line was really crooked. Let's say this is where Cassie is right here, okay? And so we need everybody equal to and below. What does it look like that we need to get? What value is this? What value is at the mean and in the tail?
Well, it's negative, isn't it? On the negative side.
It's, yeah, our z-score is on the negative side, right? And we're looking right here and we're looking at everybody equal to and below.
Mm-hmm.
So what that is C column,
Just
right?
oh, beyond, yeah.
Yeah, to infinity and beyond, right? It's negative, so it kind of throws us off. We're like looking at the other way, but that's all that is. So a percentile for, let's, you know what, hold on, let's see. I could probably just add it into here, huh? For a negative z-score, all it is C column. That's it. Easy peasy lemon squeezy. So let's find 1.2. Just in case, I don't know, do you guys have your stuff with you or no?
Yes.
Oh, you do? Okay. I was just wondering, but just I got over here anyways. Okay, so 1.2, right? So Susana, it's negative 1.2, but there's no negative 1.2 in here. Doesn't matter. We still just look at the same columns, okay? And so we look right here at C column and we get 0.1151. Okay, 0.1151.
Mm-hmm.
And that's all it is.
Oh,
It
it's
is-
just
It is that easy.
oh,
There's-
you don't add anything. Why was the other one adding and this one isn't
Yeah.
adding?
Let me write this down before. What did I say? 1151 or 1150? I forgot real quick.
It was 1.
Thank you. And Natalia, I'll come right back to you real quick. So Cassie's percentile is 11.51. Okay, that's Cassie's percentile. All right, Natalia,
Mhm.
why do we add, if it's a positive z-score, it's above the mean?
Okay.
And so what we're somewhere over here, right? I don't know where, it doesn't matter, but we're above the mean. So when we look at B column, all it's going to do is take us up to the mean. Remember, B column is from the mean to the Z. So all it tells us is that little chunk or that sliver right there. Okay. But that's not the percentile ranking because it's everybody below him. And we can't leave out all of the people that are below the mean also.
Oh, okay.
Does that make sense?
Yeah.
So we need everybody below the mean plus that B column that adds that extra little bit of proportion.
I see.
Okay,
Yeah.
good. And then the negative, well, we don't have to add because it's everybody equal to and below you. And that's kind of the cool thing about C column is it's already telling you that. Okay.
Okay. Perfect.
Yeah. It's kind of fun, right? Kind of.
So the answer is 11.51%.
That's right.
Okay.
That's right. And it's a pretty low percentage, right? It's pretty low because Cassie was below the mean and there's not very many people left in the tail down there. Okay, so whatever this score is, whatever they tested for Cassie, she is only equal to and above 11.51% of the people out there. Okay, if we wanted to, I know it's the MMPI, but that's kind of hard for us to visualize. So what if it was intelligence? Right, she would only be equal to and smarter than 11.51% of the people. okay? If it was height, how tall she is, she would only be equal to or taller than 11.51% of the people, okay? If it was weight, right? If it was weight, she'd only be heavier than 11.51% of the people. At this point, we'd probably be looking at anorexia, right? Because she'd be so skinny, okay? Or maybe she's like a marathon triathlon or something, triathlete, okay? Yeah, that's the fun part of percentiles. So I don't want to go too much longer because we're about an hour or a little over, and it's hard for me to upload them if we go too far. But immediately, are there any questions over this? Not
Well, I do have a question, but like it's not it's kind of related to this.
okay. That's okay.
The pages are 368.
Three. I think just flip flopped. 386.
Oh
Oh.
yes, I'm sorry.
No, that's all right.
Okay. Then.
Yeah, 386 and 387. And just in case, Christy, you know, they're here for you too. Okay. The slides are there for you. They're saved. And if you want, I could just put these up as a file and attachment, and you could print it out separately and not have to worry about the slides if you want me to do that. And you could just print it out and have it there. Okay, I can do that too. I'll just put them under documents, and I'll put like the normal curve table, okay, or the Z table.
Well, it's fine. I just wanted to make sure because like the last pages, there were like a lot of graphs and I didn't know which one it was.
Oh, I know. Yeah, there's so many. Yeah, 386 and 387. Okay.
Yes.
So tomorrow, guys, you know, I'll pretty much keep doing the same thing, and I know it's hard. I know you know, and obviously you don't have to. But if you wanted to come back, if you need a little extra, we'll just pretty much be going over the same thing tomorrow. I'll try and use different examples. So if you make it, or if you just watch the video, it'll just be another going over these and different examples just to really hammer this home. Okay. But try and, you know, work on that homework assignment so you know, and if you have any questions, you can email me, you know, you could ask on our chat, on our discussion board, so that other people could see it and they can chime in and they can learn also, and I'll answer too, okay? So that always helps when there's like collaboration and people are kind of working with each other too, okay?
Okay, and then we have a test this Friday?
Yeah.
Or an exam?
Yeah, it's supposed to be Friday. I'm probably going to extend it. Maybe I'll do it like Thursday through, you know, Monday or something like that, and just have quite a few days, just so it's not so stressful. Okay.
Okay.
And
it's going to be covering this material, basically?
Yeah,
or?
really just this stuff, like chapters 5 and 7. Okay. No 6. Skip 6, and then it's not everything from 5, and it's yeah, probably everything from 7, but yeah, 5 and 7.
So the questions will be similar to the homework assignment?
Yes.
Okay.
Okay. Yeah, for sure.
Okay, sounds good. Thank you.
Okay, you're welcome. All right, any other questions?
Yeah, as I'm doing this for one of the questions in the, I guess the multiple choice ones, I try to find I don't know if this is right, but for number 6, would it be that it's just C?
Yes. Yes, yes, C is right on that one. And I don't really like those questions or the answer choices. Central tendency, is your mean, median, and mode, okay? The variability of a distribution, I could see that one could kind of get confusing.
Yeah.
And the only reason why is a z-score is standard deviation, right? Z-scores are how people are standardly deviating from the mean, all right? But this next one, the relative position of an individual, which again is kind of confusing because you're like, what? But that's what a table or a Z distribution is. It's letting us know where are these individuals on a Z-score related to each other or relative to each other. Okay, so yeah, it is C. That one is confusing, but yes.
Okay.
Okay,
to-
yeah. And